Assalamu alaikum everyone. Today we are going to start May June 21 to 1. Okay. So okay. Let's start from organic. I think. Okay. Ethane dioic acid. And here you got the formula. Dioic acid means there are two carboxylic acid groups, molecular mass of 90. Okay. So its MR is provided to you. In the first person, they are asking, explain what is meant by the term relative molecular mass. So these are the definitions that you guys need to remember. So we can write that uh, it is the weight average mass of the molecule compared or related to the one-twelfth mass of an atom of carbon-12. Or you can say that on a scale, instead of this, that on a scale where the carbon-12 atom has exactly 12 units, you can write that as well. Okay, so this is the definition. Now they are asking for to state the empirical formula of the ethane dioic acid. So if you see it's ethane dioic acid, it's C2, right? H2 and O4. So if you simplify it, it is going to be CHO2. So you can write it as CHO2 or CO2H. In either way, it is considered as a correct. Is this clear? Now, calculate how many atoms of carbon are present in 0.18 gram of ethane dioic acid. Show your working. Okay, so basically this part is very easy if you see. See, they have provided you the mass, the MR, and in the formula, how many carbon atoms are there? Two carbon atoms are there, right? Is it still delaying, Musfira? So if you see the formula, it's C2O4H2, and it has how many carbon atoms? We are seeing that two carbon atom. The MR of the compound is 90, and in that 90 gram there are two carbon atoms, which means there are 2 times 12, which makes it 24. So there are 24 carbon atoms, right? Now, if instead of 90 we have a 0.18 gram, then how much carbon atom, what is the mass of the carbon atom? So it is going to be X. So if you calculate the X, you will get the mass of carbon atoms present in 0.18 grams. So it is going 0.18 times 24 divided by 90. Yes, can anyone tell me the answer? I think if you are experiencing a delay, so check your connection, might be there is a problem. If anyone else also experiencing the same problem. Okay, they are asking for how many atoms. So 1 minute. Yeah, here we got the gram. So we don't need a grams, right? How many atoms of carbon are present? That's they are asked. Sorry, how many atoms of carbon are present? Okay. So if it's a 90 gram, then how many moles is it? Can anyone recall? 90 is the MR. Yes, wait, Ishal. If 90 gram is the MR of the compound, then how many moles are these? Isn't it 1 mole? Right? And if you see in this 1 mole, how many carbon atoms are there? There are 2 moles of carbon atom, but they are asking not the moles, they are asking for the number of carbon atoms. So can I say that the number of carbon atoms are actually 2 times 6.02 exponent 23 in 90 grams of uh, ethane dioic acid. Is this understandable? That there is a 90 gram of ethane dioic acid, and in this 90 gram, as it's a 1 mole because it's equals to its MR, 90 gram is the MR. So there are 2 carbon atoms, so it means there are 2 moles of carbon atoms. So if I have to find the number of carbon atoms, I have to multiply the 2 with 6.02 exponent 23. Yes, this ratio is clear to all of you. Yes, if anyone has any confusion in this, please ask. Okay. Okay. Now they have provided you the mass, which is 0.18 grams. So in 0.18 grams, how many number of carbon atoms? They are going to be X. So if I calculate the X, which are the number of carbon atoms, so X is equals to 0.18 times 2 times 6.02 exponent 23 divided by 90. So 45, can anyone solve it and tell me the answer, please? Yes, can anyone tell me the answer, please? 245. Okay, 2.4. So 2.408 exponent 21. So this is the number of carbon atoms present in 0.18 grams of ethane dioic acid. Is this understandable to all of you? Okay. Now, next part. Solid ethane dioic acid reacts with aqueous calcium ions to make a precipitate of calcium ethane diode. So see, precipitate are forming, it means it insoluble. Okay. If precipitates are forming, means it is insoluble. That is the formula of calcium ethane diode. Breaks down when heated to form calcium oxide, carbon dioxide, and carbon monoxide. Construct an equation to represent the reaction of calcium ethane diode when heated. Include states. Okay. So you will see they clearly stated that it breakdowns when heated. So it means if the examiner asks you the type of a reaction which actually the examiner asked you here, so which type of reaction it is? Yeah, you can round it off over here as well. Otherwise, it's fine. If I round this off, so it is going to be 2.41 exponent minus 21. So if you round it off, it is going to be 2.41 exponent 21. Okay. Yes, very good, Hassan. So see, the examiner here mentioned that it breaks down when heated. So on heating, if something is broken down, then that type of a reaction is called thermal decomposition. So see here, the identify the type of reaction occurs when CaC2O4 calcium ethane diode is heated. So the answer over here would be thermal decomposition. Okay. Now here, construct an equation. The previous part. You have to construct the equation and you have to include the state symbols. Here, examiner have asked you. And another thing, examiner didn't ask about balancing it, but you have to balance it. That's the important thing. Okay. So CaC2O4 calcium ethane diode. So as it forms a precipitate, so it means it's a solid. When heated to form calcium oxide is an ionic compound. So what would be its state? Yes, what will be its state? Yes, very good, Mariam. It's solid. Then carbon dioxide, we know gas. Then after carbon dioxide, we have carbon monoxide, and it's a gas as well. So if you see, okay, the equation is all balanced. There is no need to balance the equation. One calcium over here, one calcium over here, two carbons over here, two carbons over here, four oxygens, one, two, and one. So four oxygens are over here. Okay. Now, next part. Identify another compound containing calcium ions which will produce carbon dioxide and calcium oxide when it is heated. Yes, can anyone recall any compound which on heating produces carbon dioxide and calcium oxide? Yes, very good, Hassan. Calcium carbonate. So if you recall the metal carbonates, all there is a metal carbonate. Whenever the metal carbonate is heated, that is the general equation for the group 2 metal carbonates. It turns into metal oxide and carbon dioxide gas is formed. So here, calcium carbonate solid on heating forms calcium oxide, which is solid, and carbon dioxide gas is liberated. Yes, is this clear to all of you? Yes, Kubal. Okay, now, next part. Carbon monoxide gas and gas are both diatomic molecules. The diagram shows the arrangement of outer electrons in the molecule of carbon monoxide. Okay, we have discussed this in our lectures as well when we were doing dative bonding. State one similarity and one difference in the way the atoms in carbon monoxide molecules are bonded together compared to the atoms in a nitrogen molecule. You have to tell one similarity and one difference. So when we talk about a similarity, if you recall nitrogen over here, molecule N2, in nitrogen, both the atoms share three electrons with the other to form three bond pairs, and both have one pair of electron over here. So the one similarity is that both have a triple covalent bond. or in both the molecules between the atoms, uh, three pairs of electrons are shared. So that is the similarity. So one similarity is both carbon monoxide and nitrogen forms triple covalent bond. Now, the difference. So the difference is very visible. If you see over here, this is a pair which is made from both the atoms. This is a pair which is made from both the atoms. But this pair comes from oxygen only, right? So here if you see, this is a covalent bond. This one is a covalent bond, but this one is a dative bond. So in carbon monoxide, there is a one dative bond. But if you see over here, each pair is forming covalent bond, and in nitrogen, so there are three, all three are covalent bonds, not no dative bond. Is this understandable to all of you? So in carbon monoxide, one of the bond is dative, but in nitrogen, all of the bonds are covalent. Mariam, that is the nature of these molecules. If you read this, state one similarity and one difference in the way the atoms in carbon monoxide molecules are bonded together. So we have to talk about the bonds, the pair of electrons. So that is the correct thing, that carbon monoxide is polar and nitrogen is not non-polar, but we can't write it over here. Okay. Because we have to tell the difference in bonding only. So the bonding one are forming a dative bond and the other one is forming a all covalent bonds. Is it clear, Mariam? Okay. Now, next part. The table states the electronegativity values of carbon, nitrogen, and oxygen. Okay. 2.5, 3.0, 3.5. Use the electronegativity values and relevant details from the data booklet to complete the table below. Okay. I'm telling you again now, remember there is a no need of just give me a minute, please. Okay. So now there is a no need of a data booklet. Instead, the information is provided to you along with the question, and constants and periodic table are at the end of the periodic table. Okay. Are at the end of the paper where the periodic table and the constants are given. Number of electrons per nitrogen molecule. Okay. Okay, per molecule. So it's, I think, very easy to find. If we look at nitrogen, nitrogen's atomic number is 14, right? So it means 14 protons and 14 electrons, and it's N2, so there are okay. No, sorry, 14 is the AR, my bad. 7 is the proton, the atomic number or the proton number. So there are 7 protons and 7 electrons. Okay. So if you see over here, here you got a periodic table. So see, the above value, the top value over here is the atomic number. So it's 7 over here, right? So there are 7 electrons, and in nitrogen molecule there are 2 atoms, so which makes 7 electrons for each atom, makes it 14. So over here 14. Now, if you look for carbon and oxygen, oxygen has 8 and carbon is 6, right? So for carbon, it's there are 6 electrons. For oxygen, there are 8 electrons as these are atoms. So 6 plus 8 is also 14. So here I'm also going to write 14. Okay. Now, types of intermolecular forces. Yes, here you have to apply that knowledge about the polarity and non-polarity. So we know that in nitrogen, both our atoms are same, so it must be non-polar, right? And in carbon monoxide, it must be a polar one because there is a difference in the electronegativity. So if the molecules are polar, then what type of intermolecular forces are present? Yes. And if the molecules are in non-polar, then what type of uh, intermolecular forces are present? Yes, very good. So in a polar one, the most strongest intermolecular forces are permanent dipole dipole forces. Okay. But beside this, they do contain temporary dipole-dipole forces as well, or induced dipole-dipole forces as well. Instant. And here, as it's a non-polar, so the intermolecular forces are either temporary or instantaneous dipole-dipole forces or temporary dipole-dipole forces. Is this clear to all of you? Okay. Now, nitrogen is less reactive than carbon monoxide, even though nitrogen has a lower bond energy than carbon monoxide. So just why carbon monoxide is more reactive than nitrogen? Yes, who is going to answer this one? Yes, Hassan, very good. See here, Mariam, here we can write. And Hassan, yes, it's due to the difference in polarity. It's a non-polar, so it's not going to, you know, remember the permanent the dipole forces only influence the physical properties, not the reactivity. Okay. If they are stronger, then the melting point, boiling point gets stronger, gets higher, the density gets high. And if they are weaker, then the melting point, boiling point density becomes lesser. So nitrogen is non-polar. So it has no dipole. So it is not going to, attract any charge species towards itself, and it's a polar one. So due to the polar, it can easily attract any charge species towards itself to react with. So here you are going to write that it is because carbon monoxide is polar molecule or is polar. Is this clear to all of you? Okay. Now, both carbon monoxide and nitrogen are gases at room temperature and pressure. Okay. They both behaves like ideal gases under certain conditions. State two conditions necessary for these two gases to approach ideal gas behavior. So if you recall, to behave like an ideal gas, there would be no or negligible forces of attraction between the molecules, and no or negligible forces of attraction between the molecules only be obtained when we increase the temperature. So high temperature makes the gas expands and the molecules gets further and further away. And low pressure. When we decrease the pressure, the molecules gets further away from each other, so they are present at a distance that their intermolecular forces becomes insignificant. Is this understandable to all of you? Okay. Now, explain why nitrogen behaves more like an ideal gas than carbon monoxide does at 20 degrees Celsius and 101 kilopascal. So here, the answer which Kubra, you were saying that permanent dipole forces are stronger. Yes, it has a permanent dipole forces PDD, right? And it has a temporary dipole forces or instantaneous dipole forces. So its forces are weaker. So it can get further away the molecules of nitrogen as compared to carbon monoxide, which makes nitrogen behaves more like ideally as compared to carbon monoxide. So here I'm going to write that the intermolecular forces in carbon monoxide are stronger and more significant than in nitrogen. Clear to all of you? And you have to mention that why is it so? As CO is or carbon monoxide has permanent dipole while nitrogen has induced or temporary dipole. So it's for 2 marks, so we have to mention this as well. Okay. Now next part. Okay. Calculate the amount in mole of pure nitrogen gas which occupies 100 centimeter cube. This is the volume at 101 kilopascal. That is the pressure. And 20 degrees Celsius, that is the temperature. Use relevant information from the data booklet. Okay. So see, these are not standard conditions, and when the conditions are not standard, then we always use the formula. See, they have seen you that it's an ideal gas. So we use this formula. PV is equals to nRT. And you have to find the amount in moles. So it means you have to find the N. So the formula would be changed into N is equals to PV over RT. So remember, we always use the pressure in pascals, not kilopascals. So I have to multiply it with 1000. The volume is always used in meter cube, so I have to multiply it with the exponent 6 to convert it. The temperature is always in Kelvin, so I have to add 273 over here. And further, we need a R. R is a general gas constant, and its value is provided to you guys, and it's 8.31. It will be in the second last page of the paper where the constants are given. Yeah, it's always 8.31, right? Okay. So for a pressure, if I multiply it with 1000, it turns into 101,000. Volume would be, no, sorry. We are converting into a bigger volume in a bigger unit. So it must be divided by exponent 6. So if you divide it with the exponent 6, so it means 100 multiplied by exponent minus 6. Either you will write exponent minus 6 or either you will write uh, divided by exponent 6. Just give me a minute, please, everyone. Okay, fine. Now, so divided by R, which is 8.31 times T. So 20 plus 273 would be 293, right? So multiply by 293. Yes, can anyone tell me the answer, please? Yes, can anyone calculate it and tell me the answer, please? Okay, it's 4.15. Yes, we all use three significant figures. So 4.15 exponent minus 3. So 4.15 exponent minus 3. Is it clear to all of you? Okay, now we have a question number 3, then 4 and 5. Okay, so we will start question 3 and then 4 and 5 will be continuing in the next class. Okay. Sodium halide salts means NaX, X can be chlorine, bromine, iodine, reacts with concentrated sulfuric acid at room temperature. This reaction we have discussed. Write an equation to represent the reaction of NaCl with concentrated sodium sulfuric acid. Okay. So if you recall, it's just a displacement reaction where sodium chloride reacts with the sulfuric acid and it displaces one hydrogen, making sodium hydrogen sulfate. Right? And HCl is formed. And due to the HCl, you are going to observe the white fumes. Okay, but you can write this equation like this as well. For example, sodium chloride reacts with sulfuric acid. So it is going to form Na2SO4. The two hydrogens would be substituted. So in this case, you are going to use 2 moles of sodium chloride, and here we got 2 moles of hydrogen chloride. And remember, in this reaction, these formed as a gas. So if the examiner asks you to, so yes, the last paper we have ended in the yesterday's class. Today we have started the new paper. Name the type of reaction. So see, a hydrogen is being displaced by a sodium, right? So it's a displacement reaction. Now, sodium iodide reacts with concentrated sulfuric acid at room temperature to form the steamy fumes. Identify the chemical responsible for the steamy fumes. So see, here it is responsible for the steamy fumes, right? So when I'm reacting with the sodium iodide, then which substance would be responsible for the steamy fumes if they are formed? No, we can't write acid-base reaction actually because see, it's not a base, it's a salt. Hassan. Why Mariam HCl? Here sodium chloride is used, here sodium iodide is used. So isn't it the substance, the chemical substance which is responsible would be hydrogen iodide, HI? Oh, okay, I'll check that, Umar. Okay, now next. The reaction of sodium iodide with concentrated sulfuric acid continues, forming several other products, including a dark gray solid. So if you recall that the dark gray solid would be iodine. Just guys, give me a minute, please. Okay. Okay, now identify the chemical responsible for the dark gray solid and one other product of this reaction. So the dark gray solid we have already identified, that we know it's iodine, right? Either you can write the name or you can write the substance, the formula, other product. So in this case, if you recall, with the iodine, the other product would form, if you check the equations, it is either sulfur or H2S, hydrogen sulfide gas. So these two would form, and then when we react with the sodium bromide, we will get the uh, sulfur dioxide gas. So I am keeping this class till here. Okay. From here onwards, we will continue in our next class and we will be going to end the whole paper. Okay. If any one of you has any confusion, please ask.